Okay, hello, this is Rani Ahmed with you. This is lesson 6 in Objective-C programming on the operating system Macintosh OS X or OS X. So on this lesson I'm going to talk about how to use mathematical functions and from where we can retrieve them. Now in Objective-C we have here this header, okay, which is called math.h, okay, and from this header we can retrieve functions like the power, like the trigonometrical functions like cosine and sine and tangent and cotangent and arcsine and arccosine, and also we can get the floor and the ceiling, okay. Those are to give us the next or the previous number after or before the number with a fraction, okay. We see that, and also we have how to get the square roots, okay, and maybe also how to get some other roots, okay, like cubic root. So let's start. We start with, for example, two numbers, okay, x2 equals 2 and y equals 64. Now, why did I choose those numbers? Now, in we talked last time about 64-bit and 32-bit, you know, so we need the power to get that maximum number, okay. So the power is as a definition is like the repetition of the multiplication. So if you want to say 2 to power 64, okay, you have to say this is equal to 2 times 2 times 2 times 2 times 2, like this, all the way, times 2 64 times, okay, repeated 64 times. So this is annoying if you want to write this. So what we do is there's a function named pow which does the power and takes two arguments. See, it takes two things here. Those two things are called parameters or arguments, okay. So here I have x and y. I'm substituting right away, okay, and I want to put here .2f for precision's sake, okay, because anyways the number will be an integer, okay, but I'm setting it in a double, so there is no harm doing this. And this is running it. So this is 2 to the power 64. Okay, this is how big can a computer handle of addresses. This is the maximum number of addresses that the RAM can hold, okay, and that's why, because I mean in nowadays, okay, 64-bit, this is the 64-bit limits, okay, this is the number of addresses, number of bytes that that's a maximum, okay, for a computer to hold these days. But in 32-bit it will be this one. Okay, so it's very much smaller, okay, and that's why we have a limitation of 3.2 gigabytes of RAM in 32-bit operating systems, even though there are solutions for that on a 32-bit system, but still that's the case, okay. Now this is all about just usual power, okay. Now how can I get the square root? Like, for example, I know what would a number multiplied by itself to give you twice, I mean multiplied by itself twice, okay? So it can give you, for example, 64, so it will be 8, okay? 4 is the 2. 36 would be the 6. So how to get that? We use the function named sqrt, okay? And we use here, for example, 4 would give you 2, okay? Maybe we said 36, okay? This is 64. Okay, I'm not having fun, by the way. I'm just trying to show you what is a square root, okay, for those who don't know what's a square root, okay? I want people to learn programming too. So you can even do this, and this is almost the number because I put here precision. That's why I say it should be longer than this. Okay. So this is all about the square root. Now, what if I want to get the cubic root? What do I do? The easiest way is that there is a rule that you use the power, okay? I mean pow, wow, and then you wanna find the cubic root of 8. So what's multiplied by itself 3 times to give you 8, okay? So I would put this way. First of all, you have to put it in a fraction like 1 point something, okay, over 3, so to give you the cubic root, because otherwise it will be considered like Euclidean division. It's not a real or float division, okay? Real number or a float number division, okay? So that's how we do it, okay? And this is, so this is 2, okay? Yes. So because 1 over 3 will be giving you the power of 0, therefore it will be always 0, okay? And that's wrong, okay? Here, let's make a test. See, that's wrong. It should be 2. So that's why I put 1.0. Okay, so this is how you get the cubic root, or whatever root you want. So if you want, for example, the root like, let's say 64, I'm going to get over 4. What's multiplied by itself? So let's see. Okay, so this is almost that, you know, like so this is like what's multiplied by itself 4 times, like let's say 16. We should get 2 again. Okay, so this is how you get the powers and the roots of whatever rank you want, okay? Now going to trigonometrical functions, okay? Now before that I want to explain this to you, okay? First, what's the cosine, what's the sine, what's the tangent of an angle? Those are all related to angles, okay? And I must add also the here the a cosine of x, and there is also a cosine of, let's not say x. Oh shit, let's delete this. So it will be a cosine of some value, not an angle, okay, to give you x, okay. And there is also the a sine, and also would be, and for example the a tangent of b. Cool. To give all of them just to give you the same angle x. Okay, so the x has to be, okay, x has to be in radians, okay, not in degrees, not in degrees. So because of that I need the number also named pi, okay, which is equivalent to 180 degrees. Okay, so let's explain more. So the sine is what the length of this if you have a right angle triangle, okay, this is a right angle triangle, okay. So let me fill it with a small square over here. Okay, so this is a right angle triangle. Good. So if you have a right angle triangle, the sine of this angle, which is always fixed because it's a ratio, okay, on a fixed angle size, okay, on a constant angle size. However, the opposite increases and the adjacent increases, I mean the hypotenuse increases in length, so the sine will be all the time the same. So the sine is the opposite over the hypotenuse, okay, and the hypotenuse is this line facing the right triangle, right angle, I mean, okay, which is the 90 degrees here in the triangle. So next, the cosine is this adjacent side, the length of it, over the length of the hypotenuse, okay, that's the cosine, okay. And the tangent of the angle is, by definition, is that, or just by conclusion later in mathematical theories, so you get the opposite side, the length of the opposite side, and divided by the adjacent side, okay. However they grow, you'll get the same tangent value. Okay, now but here I'm talking about using a radius, not in degrees, so we needed pi. So to get pi, okay, the cosine, this is just like a given, I'm giving it to you, okay. So the cosine of 180 degrees, 180 of pi, okay, equals -1, okay. So using a cosine I can get the pi. The pi is approximately equals to 3.14 something. Yeah, there. Okay. Anyways, so let's go and apply all what we talked about. So right away what I do is go to Mac, go here, and then so I want to get I need pi. Why? Because through pi, because it's like half a circle, 180 degrees, I can later divide the pi into as much as I want, so I can transform the 180 degrees, okay, and get from for example the 60 degrees, which is 180 divided by 3, okay. So therefore it will be pi over 3, okay. So pi, okay, float pi, okay, this is to get the exact number, float pi, or float pi, yes, equals a cosine of -1. Cool. So I'm gonna print first pi to tell you exactly how much pi is. I'm sorry, I forgot the semicolon. It's very important. So this is almost 3.14 as I told you, but here I have a position, so this is almost, it's a very very long number. Okay, now, so this is how I get pi. So if I want to get the cosine of 30, or no, let's say the sine of 30. Sine of 30 is half, so let's say it's 30 degrees, I mean. So it will be pi over 6, because 180 over 6 will give you 30 degrees. So it is sine of pi over 6. Okay, I bet you're gonna get 0.5. How is that? So that's our rules we memorize at school, so you should know. And this is cosine. It will be radical 3 over 2. Okay, square root of 3 divided by 2. And here, if you wanna make sure, let's print radical 3 alone. So and percent of here, and here let's say pow sqrt of 3 and divided by 2. Okay, so just see that they are both almost the same. Okay, they are the same. So I'm saying that this is radical 3 over 2. Okay, I'll delete this. Okay, so this is what's the cosine of 30 degrees. Now the tangent, I think it was radical 3 over 3, I don't recall it. Okay, yes, that's the tangent. Okay, so this way I know the tangent, the cosine, the cosine, all that. Now there's the floor and the ceiling. Okay, the floor and the ceiling are the following. Okay, now we know that pi is this. Just forgot about, let's delete this sqrt thing. Just as a reminder, I must print z as the pi. Okay, now what if I want to just get the 3 from the z? So what do? I use the function named floor. Now last time I used my way of truncation. Okay, like getting the integral part only, but floor can give you the integral part right away. How? If I say, for example, floor of pi. Okay, so it will give you the 3 alone. Why? Because the floor is like, what's the floor of the fractional part, the decimal part of the number? Okay, what's the very next number if I zeroed, or what would be the number if I zero the decimal part? Like I make all this part zeros. Okay, so it will be this, the floor of it. It's the level directly below it. Okay, and the ceiling, what would make this number, okay, 0 again, to add and make this to the next number. Okay, so what would be the next number? This is the ceiling. What would be the next number of the integral part? Okay, so the floor will be 3 and the ceiling would be, or will be, not would be, will be 4. Okay, so this is a floor of pi and we get 3, and this is the ceiling of, I should get 4. Okay, and got it. So I hope you enjoyed this lesson. There are other functions you may enjoy reading about them online. Okay, and I hope you liked this lesson, and please subscribe using your registered YouTube account. It's very important so you can follow up my lessons, and please tell me your comments about the lessons. Thanks.